Hello, my name is Jan Dąbroś and I'm working at SemiHealth. It's an embedded software company based in Poland. I would like to talk to you about coreboot unit testing work which we have done this year. Actually, motivations for this work, what were the challenges, what is the current status in the upstream tree, and finally, we'll talk about plans for the future. Okay, so first thing, motivations. The basic motivation is quality assurance, right? So the more testing, usually the more testing, the more reliable code we have, right? So this is actually the base of all this work. Before unit testing were merged into the tree, what was the state of testing inside coreboot repository? First of all, there was Jenkins test system, which is doing only a build tests. Another is on-target test system. This is in development by 9 Elements, and this is hooked into Jenkins, but it's not gating yet. So we, together with Google, start the process of creating unit testing framework, and I would like to talk to you about what it's all about. Okay, so first of all, what is unit testing? Let's take a simple example of 3 files, which are compiled and linked to the final executable. In my example, I have 3 files, but in coreboot it's a way more files, and such compiled binary is executed on target. We can apply integration testing to such binary. In the unit testing, we are taking one compilation unit and isolating this from the other units, implement test harness, which is validating the API of this unit under test. And on host machine, we are compiling, link them together to create a test binary. And this test binary is executed on host machine. And this way we can verify the API of our unit under test. This is a simplified schema, since usually file is dependent on other files, right? And in such case, we need to mock out or stub API of these other modules, which are not part of our unit under test, right? And sometimes, especially in case of coreboot firmware, such dependencies are very complicated, so it's very difficult to mock them out. In such case, we need to include another module into our compilation and link against such a model. But in principle, we would like to isolate only one compilation unit and test API of such unit. Okay, so what are the benefits from unit testing coreboot? First of all, this is very quick. I think this is the most important advantage of unit testing. So as of now, the whole suite tests for all the modules which are in the tree. Build and execution time is something around 2 seconds. So we can run a lot of these tests. Actually, we can also apply test-driven development. So first, we are writing tests, and then we implementing code which fulfill the requirements of these tests. It's so easy to build and run, much easier than integration testing. So this allows us to run them again and again to quickly verify if our code is performing good. For sure, there is another benefit that when you improve, writing tests allows you to improve the code quality, since easily testable code is better code. This applies for coreboot firmware only to some extent, since firmware has constraints regarding both image size and execution time. But to some extent, we can improve code quality by making it testable. Okay, so what's the current status as of November 2nd, 2020? We have 7 modules merged into the tree, tests for 7 modules. 4 are in progress. We have 6 contributors, and not only from SemiHalf and Google, so it's good. We would like to have more. There are 2 documents, introduction and step-by-step tutorial how to write unit tests. And one more important thing, maybe not all of you know that every commit which is sent to the Gerrit is part of Jenkins build. So Jenkins is running unit tests for every patch which landed in Gerrit. This is one of the gating items. Okay, so I would like to talk about some challenges which we had during our development and which we have even today. I selected 3 of them. Very first challenge was to select unit testing framework, unit testing library. This is a library which provides us assertions, mocking features, and so on. So we had to decide whether to implement our own custom library or use some already existing one. There was a lot of candidates, including Google tests, CUnit, SputUnit, Unity, and others. And finally, we decided to use CMOCA. This is very easy to use library, lightweight, portable. It's rated fully in C, so there are no extended dependencies. It has support for text features and mocks. Of course, there are some drawbacks. For example, CMOCA requires to register every test case, but it's not a big deal. And if you want to know more details about the selection process, there is a document which summarizes all this process, candidates, and why we selected CMOCA. Another challenge related to actually unit testing C code in general is that sometimes you need to access static internal variables of unit under test. And so, for example, a lot of modules have a global static variable which is used to keep the state of whole module across different functions from the API. And in the test, you need to clear the state of this module in order to have test cases isolated from each other. So basically, how we can do this? There are two solutions. First, you can modify unit under test, so firmware code, and remove static specifier if you are building tests. So first of all, you need to change source code. And another problem is that there is a difference between test binary and final executable binary. Of course, this will never be the same, but we try to keep them as close to each other as possible. So another option is to apply white box, so-called white box unit testing, and include unit under test module into our test harness. So this is something which may sound weird to the developer, since not usually we have a C module including another C module, but there are a lot of the advantages for this. You don't need to modify firmware code, and you have almost the same binary for this particular module. So here is a basic example for IMD CBMEM module. There is a global static variable, static struct IMD, and in our test harness, we need to reset state of this. So it's very simple, since if you including unit under test, then you can simply access every function, even static, right? Since at compilation time you can access them. And the last challenge which I want to talk about is about kconfig and which config should be used for building tests. Currently, unit tests are using QEMU x86 config, and this is not ideal since we have some assumptions, like for example architecture and usage of ACPI, etc. Also, this may bring some weird issue for the developers, since they won't be sure why code behaves this way. So how we want to solve this? Basically, the idea is that we'll have all no config, and the developer writing tests needs to provide valid values for all configs which are used by unit under test. And there will be two possibilities: either to statically define configs simply by compilation flag, by C flag, or we will tweak a config macro so that it is accessing variable, not a constant macro, right? So we can then have one test harness, one module, which is using, which is testing multiple configs, right? So there may be a case where developer wants to test one module with different configs, and such solution will help us achieve this. And this is work in progress. We have ongoing discussion about how to implement this in details. Okay, so how to run unit tests. This is very easy. Prerequisites are only make, CMake for building CMOCA, since we are building CMOCA from source, and GCC, czyli GCC, so basic host compiler. The command for running tests is simply make unit tests. This will build and run whole test suite. You can also make a particular test. So this is very useful, especially for test-driven development, where you want only one particular test to build and run. And on the slide, you can see an example of I2C test. And as I said previously, every time a new commit is sent to Gerrit, Jenkins executes make unit tests. And as I said, this is a gating item for merging new commits. Okay, so in few words, how to use our coreboot test framework for this, for writing. First of all, what is the tree structure? We would like to mimic source directory structure for our tests, so that it will be easy to match a unit under test with a test harness for this particular test. As you can see an example, when we writing a test, for example, for source lib string.c, then test harness will be under tests lib string test.c. So the structure is similar to what we have under source directory. Build system is also very similar to what we have for a normal source code. When registering new tests, you are simply using makefile helper, which is in the directory where your test harness is. So first of all, you need to register your test in this makefile helper. All the magic is done by makefile variables, and there is a bunch of variable for every test which you can define, like for example config, stage, mocks, and so on. This is described in the documentation, but the most important variable is sources, right? Since we need to explicitly list all the sources we want to include in a particular test binary. So this means test harness for sure, unit under test, unless we will use white box testing, right? Since then we are simply including unit under tests to our compilation, not at link time, but at compilation time. We may also include files with mocks and snaps, since there is a couple of such in test directory. For example, for console, we have printk stubbed, so you can use this when writing tests. And as I said, we sometimes cannot mock all the dependencies because this will be too complicated. So we sometimes need to include another coreboot modules beside the unit under tests. And just a few comments how to write a test harness. So the main idea is to just call API of unit under test, add assertions for returned values for the content of buffers returned by API and so on. So this is the core functionality, right? Use mocks where necessary to mimic a hardware behavior, right? When you have a module which is talking directly to the hardware, then you simply mock them out. In such mocks, you can verify the parameters which unit under test is providing to this particular mock, right? So you are testing how unit under test is using API of another modules, what is provided there. And if you have everything in place, you just need to call test runner from the main function. You can apply setup and teardown methods, which are executed before and after the test. This is useful, for example, for mallocking and freeing memory. More details can be seen in the documentation. There's a tutorial which I wrote for writing unit tests. Okay, so what are plans for the future? First of all, better test coverage, more tests. We want to cover more and more modules. Another topic is cover lib payload. So this will require not only simply writing tests for lib payload modules, but also to modify our build system, our unit test build system, unit test framework. Yeah, so the plan is for sure to improve the coreboot unit testing framework. For example, this kconfig stuff, which I was talking about. And another plan is to improve CMOCA itself, fix bugs, we already find some, and add new features which may help us to write unit tests for coreboot. Yeah, so plans for future are actually a call for action for all of you. Ideally, we should have tests for every new code and for existing modules. Yeah, so will be great if the community also participate in writing these tests. This basically means write unit tests for your code. So there will be two benefits, both for you and for quality assurance of your code, and as well as coreboot as a whole. Please report any shortcomings, bugs, missing features of coreboot unit testing framework, and also participate in improving CMOCA. Okay, so that's all I had for you. Thank you very much.